Hello and welcome to the CompTIA Cybersecurity Analyst, CySA Plus, Certification Study Guide. In this video, we will discuss Chapter 7.1, Vulnerability Scanning Concepts. Please like, subscribe, and leave a comment. Vulnerability management, also called infrastructure risk visibility and assurance, is an ongoing examination of the organization's security. Vulnerability management seeks to answer such questions as, where are we exposed? What should we prioritize? Are we reducing our exposure over time? And even how do we compare with our peers? At the heart of vulnerability management is identifying vulnerabilities so that they can then be addressed. Searching for vulnerabilities, called vulnerability scanning, involves understanding what it is and how industry frameworks can be used. One useful means of defining a vulnerability scan is to compare it to a penetration test. Knowing the reasons for conducting a scan can also help define a vulnerability scan. However, there are also challenges associated with a vulnerability scan. Consider Rocco, who sees his doctor for an annual physical, but only because it is required by his employer. His blood pressure is taken, and it is just barely below the upper limits that would require intervention. Rocco leaves the office satisfied that he is in good health and happy that he does not have to start exercising or change his diet, that he has met the requirements mandated by his employer, and that he can wait another year before returning for his next physical. Now consider Azura, who likewise visits her physician for her annual physical. However, she does so because she is concerned about maintaining good health and not just meeting an employer requirement. Her blood pressure is taken in the doctor's office and is in the normal range. Azura also uses a wearable fitness tracker so that her blood pressure is continually and automatically monitored, and she views the results every evening with an app on her smartphone. Which patient has a higher probability of detecting a sudden and prolonged spike in blood pressure, and then immediately taking steps to manage it? Is it Rocco, who has it checked manually once per year at the doctor's office? Or Azura, who has it continually monitored? Obviously, Azura has a much higher probability of catching a change in her blood pressure than Rocco. This is because Azura is continually and automatically monitoring her health, while Rocco is only reviewing it annually. In addition, because Azura is genuinely concerned about maintaining good health and is not just having her vital signs taken in order to meet a requirement, this attitude in itself will play a role in a more proactive approach to good health. The difference between Rocco and Azura in this scenario is similar to the difference between a penetration test and a vulnerability scan. A penetration test is a single event using a predominantly manual process in which the testers act like a threat actor to find vulnerabilities to exploit. However, much like Rocco, once the pen test is over, it is forgotten about until the next time it is required. A vulnerability scan, on the other hand, is a frequent and ongoing process that is automated to continuously identify vulnerabilities and monitor cybersecurity progress. In other words, a vulnerability assessment is a cyclical and continual process of ongoing scanning and continuous monitoring to reduce the attack surface. Table 7. One contrasts a vulnerability scan with a penetration test. There are several reasons for conducting a vulnerability scan besides providing continuous monitoring. These include meeting regulatory requirements and following corporate policies. Meet regulatory requirements. Conducting a vulnerability scan is necessary to meet regulatory requirements, which is following specific actions mandated by an external regulatory body. Examples of regulatory compliance laws and regulations include the Dodd-Frank Act, Payment Card Industry, Data Security Standard, PCI DSS, Health Insurance Portability and Accountability Act, HIPAA, Federal Information Security Management Act, FISMA, and Sarbanes-Oxley Act. Although aligning with regulatory standards is important, the primary goal of a vulnerability scan or even pen test should never be just to meet compliance standards. Compliance cybersecurity standards are absolute minimal protection. In other words, compliance does not equal security. Follow corporate policies. At its core, a security policy is a recorded document that states how an organization plans to protect the company's information technology, IT, assets. The policy outlines the protections that should be enacted to ensure that the organization's assets face minimal risks. A security policy, along with the accompanying procedures, standards, and guidelines, is key to implementing information security in an organization. Having a written security policy empowers an organization to take appropriate action to safeguard its data. A policy is considered the correct tool for an organization to use when establishing security because a policy applies to a wide range of hardware or software. It is not a standard and is required. It is not just a guideline. If the question, "What is a security policy?" were posed to both a manager and a security technician, the answers would likely be different. A manager might say that a security policy is a set of management statements that defines an organization's philosophy of how to safeguard its information. A security technician might respond that a security policy is the cybersecurity configuration settings in a system. These two responses are not conflicting but are complementary. A written policy dictates what technology configuration settings should be used. Most corporate policies require regular vulnerability scans. The ongoing scanning and continuous monitoring features of such a scan can meet the goals of an organization as outlined in its security policy. Despite its importance, there are several challenges that are associated with vulnerability scanning. Some of these can even be considered risks and include volume of scan data. Vulnerability scans can produce large amounts of data that must be analyzed. Identification of vulnerabilities. A vulnerability scanner must be able to perform two tasks: locate and identify devices, software, open ports, and other system information and correlate that information with known vulnerabilities from one or more repositories of vulnerabilities. Not every identified system element may be an actual vulnerability, and if a system element is not part of the vulnerability repository, then a weakness may be overlooked. Technical limitations. Vulnerability scanning that is configured to be aggressive or intrusive can impact performance or even stability of the systems being scanned. Scanning could also cause bandwidth issues on networks. These technical limitations of a vulnerability scan could have an effect on the timeliness and usefulness of the scan. Remediations. Due to several different factors, such as a high cost to remediate or a very low risk of exploitation, not all identified vulnerabilities may be addressed. The process for making these determinations can often be challenging and highly debated. An industry framework is a set of designs for businesses in a specific industry and is based on consensus from industry representatives. There are several industry frameworks that can facilitate overall vulnerability management and specific vulnerability scanning. For example, these can assist in defining policies and procedures for implementing and managing security controls in an enterprise environment as they relate to vulnerability management. These frameworks include the Payment Card Industry Data Security Standard, PCI DSS, the Open Web Application Security Project, OWASP, Center for Internet Security, CIS benchmarks, and the International Organization for Standardization, ISO, 27000 series. Payment Card Industry Data Security Standard, PCI DSS. An example of a framework standard as it relates to information security is the Payment Card Industry Data Security Standard, PCI DSS. The PCI DSS compliance standard was introduced to provide a minimum degree of security for handling customer card information. For example, Requirement 11 of the latest standard, PCI DSS 3 2.1, states that organizations must regularly test security systems and processes, using both vulnerability scans and penetration tests. PCI DSS version 3. 2.1, which has been in place since early 2018, will be replaced by version 4.0, which goes into effect on March 31, 2024. While some requirements will be effective immediately, many will not be required for another 12 months, giving businesses a year-long transition period to implement the more challenging requirements. Version 4.0 has 63 new requirements addressing such topics as phishing, social engineering, and evolving attacks against e-commerce payment applications. The Open Worldwide Application Security Project, OWASP, is a nonprofit foundation that works to improve the security of software. Their goal is to enable organizations to conceive, develop, acquire, operate, and maintain applications that can be trusted. Currently, there are over 250 local chapters worldwide that support community-led open-source software projects. All OWASP projects, tools, documents, forums, and chapters are free and open to all. The OWASP Vulnerability Management Guide, OWASP VMG project provides guidance on the best practices that organizations can use to establish a vulnerability management program within their organization. The guide provides in-depth coverage of the full vulnerability management lifecycle, including the preparation phase, vulnerability identification scanning phase, reporting phase, and remediation phase. Figure 7. 1 shows the components of the OWASP VMG, Center for Internet Security, CIS. Over 20 years ago, a small group of business and government leaders met in Washington, D.C. to discuss an increase in cyber attacks. From that 2000 meeting, a vision emerged for an independent, mission-driven, nonprofit organization dedicated to preventing and mitigating new cyber threats. The outgrowth of this meeting became the Center for Internet Security, CIS. Through a collaborative global effort, the CIS has developed standards in the form of the CIS controls and CIS benchmarks, along with specialized technology tools to help security practitioners implement and manage cyber defenses. International Organization for Standardization, ISO 27000, the International Organization for Standardization, ISO 27000 series provides an overview of what is called Information Security Management Systems, ISMSs. It also provides terms and definitions commonly used in the ISMS family of standards. The ISO 27000 recommends best practices for managing information risks by implementing security controls within the framework of an overall ISMS. It is very similar to standard management systems such as those for quality assurance and environmental protection. These frameworks apply to all types and sizes of organizations, including commercial enterprises, government agencies, and not-for-profit organizations. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. We will see you on the next one.